before you interject and say, what the hell? I thought we were doing a volume of tetrahedron. Well, we are. And the volume of tetrahedron is very similar to the equation for the area of a triangle. If we were to find the volume of a tetrahedron, it would simply look like this. The volume is equal to positive and negative 1/6 times the determinant of few given points. So this is volume, right? Why do I have to bring that up? Why does it matter? So volume, it's length times width times height. And graphically, if you want to represent volume, that means the graph would have to be 3D oriented. So there's X, Y, and Z axis. So that means we have a point at x1, y1, z1, x2, y2, and z2, and we have an additional one at x3, y3, z3. Having what we have and knowing how to find the area of a triangle through determinants, can we figure out what I'm about to do next? And I would hope so, because you're simply just plugging in your points into this equation. Okay, so it's really not that new then, the volume of tetrahedron. The only caveat is that you have to remember the equation. Yes? Okay. And what does the positive and negative sign indicate? Well, it's chosen to give a positive volume. So here we have the equation for the volume of a tetrahedron. And you'll notice that the formula for the area of a triangle in the plane has a straightforward generalization to 3D space. And now that we understand that this video isn't really that novel, I'm assertive that we can begin with a numerical example. So let's say we have a tetrahedron in this figure. How can we use the determinant formula to deduce the volume of the tetrahedron? And, well, we just went over the equation. And it doesn't really matter which row you put. It doesn't matter which row goes in which, you're going to get the same answer. So using the equation, go ahead and pause the video, do it yourself, and I'll jump straight to it in the meantime. Okay, so we have the equation set up. It's simply 1/6 times the determinant of this 4x4, and you can plug this into your calculator, or you can expand by the second row. I would recommend expanding by the second row, because you're only dealing with 2 entries. And when you do either or, you get 1/6 times -72, which ends up being -12. Now, of course, can you really have a negative volume? No. So the volume of the tetrahedron as a final answer would be 12 cubic units. Okay. Now here's a trick question, and this has nothing to do with the given numerical example. So going back to our equation right here, when does the determinant equal 0? And there are only 3 instances, one of which doesn't really apply to this equation. So if there's one column consisting of zeros, or if a row or columns multiply each other, the determinant will equal 0, as we've covered in zero determinants. And when the determinant is equal to 0, what does that mean exactly? Especially in the context of points in space. Well, that just means that they're coplanar. And when the determinant of an object in space is coplanar, the determinant is 0. Just thought that would be useful for future reference. Okay, so we've covered finding the volume of a tetrahedron, and we found out that it's not really that big of a step out if you already know how to find the area of a triangle. And that's good. Alright guys, feel free to like, comment, subscribe. If you have any criticism, please let me know. In the meantime, stay tuned for more.